The purple solution is aqueous potassium permanganate. The colorless solution contains iron 2 plus ions. When we combine them, a redox reaction occurs. The permanganate ion is reduced to manganese 2 plus, and the iron is oxidized to iron 3 plus ion.
The fifth type of reaction has a formal name of oxidation-reduction reaction, and that's a lot of syllables. So a lot of times oxidation-reduction is reduced down to redox. Redox reactions involve what's called reduction and oxidation, and arguably this is the most important type of reaction of the 5 types of reaction. You have all been using redox reactions while you are watching this video, because breathing, believe it or not, oxygen going in our bodies is a type of a redox reaction. So redox reactions are pretty cool. Tons of examples. All right, the one in the lower right there was a permanganate. Here's an example of the formation of water, O2 plus H2 making water. And that's, of course, super important as well. So yeah, all of these, there's a lot of redox reaction types out there. Now, to understand redox, we have to know what reduction and oxidation means. So let's look at what those terms mean. But first, I must introduce my friend, Leo the Lion. And Leo the Lion says, grr. This is definitely the coolest picture of a lion I've ever been able to find. If you find one that's better, please let me know. But anyway, Leo says grr is an acronym. Leo the Lion says grr. Leo stands for lose electrons oxidized. Grr stands for gain electrons reduced. And in a redox reaction, you have something that's oxidized and you have something that's reduced. So in this case then, Leo the Lion says grr, zinc is losing electrons. Notice that electrons are a product, all right? So the zinc, the reactant, has lost electrons. Electrons are a product. That's what it means to be oxidized. Notice that the charge of the zinc on the right is more positive than the charge of the zinc on the left, which was neutral. That's another way to tell, is we're going to see that something has been oxidized. But again, lose electrons oxidized, zinc has lost electrons, it's being oxidized. Now, copper 2 plus, it can gain 2 electrons to become copper metal, copper with all of its electrons and protons. Copper 2 plus is gaining electrons, so copper 2 plus is being reduced. Notice that oxidized and reduced are always in terms of the reactant, all right? Zinc, the reactant, lost electrons. Copper 2 plus, the reactant, gained electrons. And in a redox reaction, you have to have something that's oxidized and something that's reduced. Now, sometimes in chemistry, people use oil rig instead of my Leo the Lion says grr, and that's fine, all right? Oil rig, oil, oxidation is losing electrons. Rig is reduction, is gaining electrons. I kind of like my cool lion. I'm a little bit biased, but there's nothing wrong with using oil rig. Or there's some other ones out there. If you have other cool ones, please share with me. I love these kind of things. Anyway.
When a piece of copper metal is placed in a solution containing silver ions, solid silver crystallizes on the copper. While the silver crystals grow, copper ions are also released into solution, giving the solution a blue color.
In a redox reaction, something has been oxidized, something loses electrons, and something has gained electrons, something's been reduced. And this reaction is an example of taking a piece of copper metal and you're placing in a solution of silver plus ions, probably silver nitrate. And what happens after a while, 2 things. First of all, you see that kind of mossy looking stuff? That's actually raw silver. Silver metal, when it forms, is not like silver of a necklace. It kind of looks like that. That's actually pure silver metal. And also there's kind of a blue tint to the solution. That blue color is indicative of copper 2 plus ions. So you know that the reactions happen because the copper metal has been turned a little bit anyway into blue copper 2 plus. Copper has lost electrons. It's becoming more positive. On the other hand, electrons we're going to see are so reactive. You don't want to just keep them around. All right? You want to make them react right away. The silver plus has gained electrons to make silver metal, all right? So copper has lost electrons, it's been oxidized. Silver plus has gained electrons, it's been reduced. And in a redox reaction, you better know where the electrons are coming from, i.e. the oxidized part, and where they're going to the reduced part. These are incredibly useful reactions, all right? I can't emphasize enough. If you have used a gasoline car recently, that's a redox reaction, all right? They're very powerful. Batteries in your cell phones, computers, whatever, flashlights, those are redox reactions. Breathing, as I said, are really cool. Now, sometimes seeing what's being oxidized and what's being reduced is easy, and sometimes it's difficult. So an oxidation number is a system that chemists have developed to relatively quickly visualize where electrons are coming from and where they're going to. So let's talk about how you assign oxidation numbers and do some examples of how they can help us. In this question, iron can react with copper 2 plus to make copper metal. Iron plus copper 2 plus makes copper metal plus Fe2 plus. Notice how I said iron metal and copper metal when it was neutral versions of those elements. So Fes was iron metal, Cus was copper metal. On the other hand, the ions have positive charges in metals cases. Those would not be the raw metals. Anyway, I digress. Which of the following describes this reaction? And to answer a question like this, which is about reduced and oxidized, first of all, you had better have one piece reduced and one piece oxidized. So answers C and D we can pull out. There's only two species in this reaction, and so something has to be oxidized and something has to be reduced, but you can't have two pieces oxidized and no pieces reduced, or vice versa. You have to have something oxidized and something reduced. If you have one piece oxidized and one piece reduced, then you could have a second thing oxidized or something, but that's rare. Anyway, to answer this question, what I would do is I would look at the species which are similar. So iron and iron 2 plus would be a similar combination on the reactant product side, and copper 2 plus and copper would be another equivalent example. And notice for the iron's sakes, iron is going from an iron 0 to an iron 2 plus. And the only way that can happen is if the iron 0 would lose 2 electrons. So the iron here is losing electrons, it's being oxidized. The copper 2 plus is going to copper 0. Copper 2 plus would have to gain electrons to become copper 0. Copper 2 plus then is being reduced. So you can look at the similar species to see what's happening. Now, if you're an equation person, electrons are just negative charge, all right? And notice that if you have a positive 2 copper on the left and a neutral copper on the right, adding 2 negative 1 electrons to a positive 2 copper makes this whole reactant side have a charge of 0, and that's what you want. This is the balancing of charge thing I mentioned in the last section, and it can be really helpful. You can do the same thing for the iron. Iron is a 0 on the left and a positive 2 on the right. You can only add negative electrons. So you would want to add 2 negative 1 electrons to the right side. This distinctly shows that iron has lost 2 electrons to make iron 2 plus. It's definitely been oxidized.